All right, here we go. Home stretch. So we know from before that this radius is going to be 8. And we know that the true height of the cone is 12 minus 20, or 88, 20 minus 12. So let's find the volume of the cone. It's a one base shape, so it's 1/3 area of the base times height. 64 times 8 divided by 3 gives me 170.6 repeating pi. And then volume of the cylinder is going to be area of the base pi r squared times height. That gives me 768 pi. And then if I want to find the composite figure, I just add them together. Which is going to be 938.6 repeating pi centimeters cubed. Nice. 19, the old paper towel roll. So we have the inner radius and we have the outer radius. So what I'm going to do is I'm going to find the area of the base, and then I'm going to tiny tower it up all the way up that paper towel roll. So the area of the base, the bigger radius is going to be 6. The smaller radius is going to be 4. So it's pi r squared of the big minus pi r squared of the little. It's going to give me 20 pi. And then all I do is I take that area and I multiply by the depth of the shape. It's going to be 240. 240 millimeters cubed. Boom. It's getting easier. Hemisphere, we don't have to worry about any bases here. We don't have to add a base or anything because it's only the area I can touch. So 4/3 pi r cubed divided by 2 is going to be what I want to use for this one. So 4/3 times pi times r cubed divided by 2 because it's a hemisphere. So if I do 8 cubed and I multiply by 4 and I divide by 3, I get 682.6 repeating. So then I just divide that by 2 and I get 341.3 repeating pi. And my units are going to be feet cubed. So 21, again, you have your hemisphere, you have your cylinder, and then you have your cone. So I'm going to do a little legwork here. I know that this is 12. So now I can do Pythagorean theorem. Oh, it's my favorite one. 5, 12, 13. 12 squared plus x squared equals 13 squared. Because we need the true height of the cone, not the slant height. All right, let's do area or volume of my hemisphere. So it's going to be 4/3 pi times r cubed divided by 2 because it's a hemisphere. So if I do 12 cubed times 4 divided by 3 divided by 2, 1152. So there's my hemisphere. Volume of my cylinder, that's going to be equal to area of the base, which is 144 pi, times the depth, or the height, which is 10. So that's going to be 1440 pi. I forgot to underline them. And then finally, the volume of the cone is going to be 1/3 area of the base times true height. Which is going to be 240 pi. Underline it. So total volume is going to equal 1152 plus 1440 plus 240. 2,832 pi inches cubed. Boom shakalaka. Last one. You got your hemisphere cut out of your cylinder. So I'm going to do cylinder minus hemisphere. And we're going to be subtracting them because it's cut out. So this distance is going to be 7. So let's find the cylinder first. So the volume of the cylinder is going to equal area of the base, which is 49 pi, times the depth, which is 21. 1029 pi. And then we need to find the volume of the hemisphere. And that's going to be 4/3 pi times r cubed divided by 2 because it's a hemisphere. So if I do 7 cubed times 4 divided by 3 divided by 2, 228.6 repeating pi. And then think about it, I'm taking it out, so I need to subtract these two numbers. Um, 800.3. That's a nice, wholesome number. Pi meters cubed. Boom. All right, Jenna. There you go. Video answer key. Hope you liked it. Peace.